titled Sequences and Series ab initio. Now the first problem of the sheet is about a set of numbers A1, A2, A3, AN being in GP. It's about a set of numbers A1, A2, A3, etc. being in GP. With first term A1 equal to A and common ratio CR equal to R. That's given in the problem, right? We want to find the sum of the products taken two at a time. Now, first of all, understand what it means by sum of the product taken two at a time. Suppose I have three numbers A, B, C. Then the sum of the product taken two at a time is like AB plus BC plus CA, right? Suppose I have A, B, C, D. Then it's going to be A, B, B, C, C, D, D, A, etc. Yes or no? All such, there will be 6 such combinations that you will get. So this is what is meant by sum of the product taken two at a time. Now where does it appear? That's the question. Where does the sum of the product taken two at a time appear? Now, for example, if I have A plus B plus C whole squared, then this is going to give me two kinds of terms. One is like A squared plus B squared plus C squared, right? That's one kind of term. The second kind of terms that you'll see is twice AB plus BC plus CA. That means this would be sum of the product taken two at a time. Yes or no? Which is A squared plus B squared plus C squared plus twice. Let me call it S2. S2 would mean sum of the product taken two at a time. Yes or no? Similarly, if you did like A plus B plus C plus D whole squared, the kind of terms you'll get would be like A squared plus B squared plus C squared plus twice S2. S2 would be sum of the product taken two at a time. That means you'll get like a AB, AC, AD, BC, BD, CD, CA, etc. All possible pairs will appear in that S2, right? Extending this to a generalized domain, that is to say, I want like A1, A2, A1, A3, A2, A3, all such pairs to appear in that sum. That's what I want, right? And that sum will appear when I carry out the following operation. If I do like a A1 plus A2 plus A3 plus AN whole squared, right? Then what all will I get? I'm going to get terms of this kind first. A1 squared plus A2 squared plus AN squared kind of terms in the first place, right? And then I'll get like a twice A1, A2, A2, A3, A3, A1, all such pairs will appear, right? That means twice sum of the product taken two at a time. This is what I'll get, yes or no? Right? Now, A1 plus A2 plus A3 plus AN is sum of n terms of a GP series, right? Yes or no? A1 plus A2 plus A3 plus AN we know is sum of n terms of the GP series whose first term is A and common ratio is R. So this one, that means summation AR. This is summation AR, R equal to 1 to N. Yes or no? This is summation AR, R equal to 1 to N is sum of n terms of this GP series A1 plus A2 plus A3 plus AN. In summation notation, that's what you write, right? That's going to be A into R to power N minus 1 by R minus 1, right? But what you have is summation AR whole squared. This is summation AR whole squared. So summation AR whole squared is going to be A squared, this squared, this squared. How about it? Right, so the left hand side is known to be summation AR whole squared. That's going to be A squared into R to power n minus 1 whole squared by R minus 1 whole squared. Right? Now if I knew this also, then I'll be able to obtain S2. I'll be able to obtain S2. Now, look, what are these terms? A1 squared is like A squared, right? A2 is going to be A into R. Yes or no? The second term of the GP series would be first term into common ratio R, right? So A2 is going to be AR whole squared, first term into R whole R would be A2. The third term would be, again multiply this by R, so that's going to be AR squared whole cubed. Up to how many terms? N such terms, yes or no? Up to n terms. That's this set of terms, right? Could be written like this. A1 squared is A squared. A2 is AR, right? A3 would be AR squared. A4 would be AR cubed, and so on and so forth. Yes or no? Do you all understand this? Now this could be written as A squared plus A squared R squared plus A cubed R to power 6, and so on and so forth. Clear? Yes or no? Which is what? Which is what? Which is what? A squared plus AR whole squared plus AR squared whole cubed, etc. Which is what? I'll just create some room because I think I've run out of space here, so I'll write on top. I've started writing the terms, the font so big. I'll just rewrite these set of terms. That means A1 squared plus A2 squared plus, see, essentially A2 by A1 is R, because this is a GP series, or in a very general sense, AR by AR minus 1 is, or rather AK, because R is a common ratio. Let me take AK by AK minus 1 as R the common ratio, right? So these are terms like AK square kind of terms. These are like AK squared kind of terms. So do you see that AK squared by AK minus 1 squared is going to be R squared? Yes or no? On squaring? That means any term divided by previous term of the sequence, A2 squared by A1 squared, A3 squared by A2 squared, A4 squared by A3 squared, AN squared by AN minus 1 squared, which will be each equal to R squared. So what kind of a sequence is A1 squared, A2 squared, A3 squared, AN squared? It's a GP series with common ratio R squared, and with first term A squared. With first term A squared. Yes or no? Oh, I wrote all that cube and all. Forget all of that. I think that was a typo. So A1 squared, A2 squared, A3 squared. So this set of terms will add up to AN squared. First term A squared. Common ratio R squared. So R squared whole to power n. Number of terms n. R squared whole to power n. It would be R to power 2n minus 1 divided by common ratio R squared minus 1. Yes or no? That's going to be this. Right? So I know the left hand side. I know the left hand side. I know this summation. So can I not obtain S2? Can I not obtain S2? Right? That is what we need to be doing. Let's look at the next problem. The next problem, that is problem 2, is about three unequal positive numbers. A, B, C are three unequal positive numbers in harmonic progression. Are three positive unequal numbers in harmonic progression. Have I told, do you know what a harmonic progression is? Right, their reciprocals will be in AP, and this would be the harmonic mean of A and C, B would be the harmonic mean of A and C, that means B would be 2 divided by 1 by A plus 1 by C, right? We want to be able to show if n is any natural number, we want to show that A to power n plus C to power n greater than 2 B to the power n, right? That is what we want to show. Clear? Now, hey, A to power n plus C to power n by 2. That's the arithmetic mean of two numbers. This number by 2. That's the arithmetic mean of these two numbers. Since they are positive numbers, this must be, and they are unequal, then arithmetic mean must be greater than geometric mean. Arithmetic mean must be greater than geometric mean. What's the geometric mean of these two numbers? A to power n into C to power n, square root of that? Square root of their product? That's a geometric mean? Yes or no? Right? Now, the geometric mean of these numbers, geometric mean of two numbers, if they are unequal and positive, will be greater than the harmonic mean of these numbers. What's the harmonic mean of these numbers? 2 divided by 1 by A plus 1 by C. That's the harmonic mean of these numbers. Geometric mean greater than harmonic mean. Clear? Hey, but B is the harmonic mean of A and C. B is the harmonic mean of A and C. Why? Because A, B, C are in HP. So B is the harmonic mean of A and C. Yes or no? So if B is the harmonic mean of A and C, what should this be? B. It should be B. B is 2 divided by 1 by A plus 1 by C. Yes or no? So this should be B because B is the harmonic mean of A and C. That will lead us to root AC bigger than B. So this is root AC to power n. Root AC to power n will therefore be bigger than B to power n. Yes or no? Will be bigger than B to power n. Clear? Which means this must be bigger than this. Which means A to power n plus C to power n by 2 must be bigger than B to power n. Clear? Which is, and this therefore must be greater than 2b to power n, which is what we wanted to prove this result, multiplying by 2 throughout, right? Let me look at 3. Let me look at problem 3. All's good? Problem 3 is about the following. It says the pth, qth, rth and sth terms of an AP are in GP. It says there is an AP and the pth term of the AP, the qth term of the AP, the rth term of the AP and the sth term of the AP, they are in GP. That's what the problem says. We want to show, we want to be able to prove that P minus Q divided by, or rather P minus Q, Q minus R, R minus S will be in GP. This is what we want to establish. We want to show P minus Q, Q minus R, R minus S will be in geometric progression. Clear? Now first of all, let me take you through this. That means we want to show that this divided by this will be the same as this divided by this. If they are in GP means what? This by this must be equal to this by this, right? Now first thing, if A by B is C by D, have I told you that each will be equal to A minus C by B minus D? Have I told you this before? If A by B is C by D, each will be A minus C by B minus D. How to prove this? Now, say I take each equal to K, right? Now let me look at what A minus C by B minus D will be. If I can show that this is also equal to K, then each of these is equal to A minus C by B minus D. Now, what is A? A is K times B. What is C? K times D. So I write A as K times B, C as K times D, right? So this will become K times A written as K times B, C written as K times D, B minus D divided by B minus D, which makes it K. Yes or no? So if A by B is C by D, then each of these will be equal to A minus C by B minus D. Similarly, you should be able to establish if A by B is C by D, then each will be equal to A plus C by B plus D. In exactly the same way, take each equal to K and show that A plus C by B plus D is equal to K. Similarly, if A by B is C by D, then I also claim that each will be equal to root A square plus C squared by B squared plus D squared. Not only that, each will be equal to nth root of A to power n plus C to power n divided by B to power n plus D to power n. All of this you can establish. Right? Now, having said this, let's proceed with the problem. Now you are equipped with some ammunition to take to this problem more seriously. Shall we proceed? Okay, so the AP that we are talking of is, say, first term A and common difference D. Say the AP has the first term A and common difference D. Right? Can you switch that off? Excuse me, can you switch that off? That hanging switch? That hanging switch? Right? First term A and common difference D. Now, the pth term of the AP is going to be what? A plus P minus 1 into D. The qth term is going to be A plus Q minus 1 into D. The rth term is going to be what? A plus R minus 1 into D. And the sth term is going to be A plus S minus 1 into D. Yes or no? Right? And TP, TQ, TR, TS are known to be in GP. Right? So then can I say that TP by TQ must be equal to TR by TS? If TP, TQ, TR, TS are in GP, can I say TP by TQ must be equal to TR by TS? Yes or no? And also equal to TQ by TR is also equal to TQ by TR. Yes or no? See, if TP, TQ, TR and TS are in GP, that means TP by TQ must be equal to TQ by TR must be equal to TR by TS. Clear? This is what I've written. TP by TQ is TQ by TR is TR by TS. If TP, TQ, TR, TS are in GP, right? Which means, and I want to show that P minus Q, Q minus R, R minus S are in GP. So now using that result, TP by TQ, as you can see, is A plus P minus 1 into D divided by A plus Q minus 1 into D is TQ by TR, which is A plus Q minus 1 into D divided by A plus R minus 1 into D, right? TQ by TR, and each must be equal to TR by TS. TR is A plus R minus 1 into D divided by A plus S minus 1 into D. Can I say all of this? Which is just rewriting the statement. TP by TQ is TQ by TR is TR by TS, because TP, TQ, TR, TS are in geometric progression. Clear? Now, enough. Do you then realize that if this is equal to this, then each will be difference in numerators divided by difference in denominators? Yes or no? Each will be difference in numerators divided by difference in denominators. If this is equal to this, then each will be difference in numerators divided by difference in denominators. Yes or no? Right? So if this is equal to this, what is the difference in their numerators? P minus Q into D will be the difference in the numerators, divided by difference in the denominators would be Q minus R into D. So which means each of this is P minus Q into D divided by Q minus R into D, right? If this is equal to this, then again each will be difference in the numerators divided by difference in the denominators. Difference in numerators is Q minus R into D divided by difference in denominators R minus S into D. Yes or no? D of course will get cancelled throughout. That means P minus Q by Q minus R is Q minus R by R minus S. That means P minus Q, Q minus R, and R minus S must be in GP. See? That's why you're getting this by this is equal to this by this. This is what you're getting from there. You're getting this divided by this is this divided by this. Therefore, P minus Q, Q minus R, and R minus S must be in geometric progression. Yes or no? Clear? Okay. Let's proceed to the next problem. So there are two APs. Two APs are there. And the sum of n terms of the two APs, say one AP is first term A1 and common difference D1, one AP. Second AP is first term A2 and common difference D2 is the second AP. These are the two APs, right? And what's given is sum of n terms of the first AP divided by the sum of n terms of the second AP. Sum of n terms of the first AP divided by sum of n terms of the second AP is given to be 7n plus 1 divided by 4n plus 17. That's given. Sum of n terms of the first AP divided by sum of n terms of the second AP is given as 7n plus 1 divided by 4n plus 17. Clear? We want to be able to find the ratio of their nth terms. That means we want to find the nth term of the first AP divided by nth term of the second, nth term of the first AP divided by nth term of the second AP. That is what we are seeking to deal with. Yes or no? Now, let me come down to this with what we need. N terms of the first AP or an nth term of the second AP. What's this going to be? A1 plus n minus 1 into d1, nth term of the first AP. Nth term of the second AP is going to be a2 plus n minus 1 into d2. That's the nth term of the second AP. Right? Now what I want to really achieve is somehow convert this expression into an expression in terms of a sum. Right? You'll realize what I'm saying here. In terms of the ratio of sums is what I want to do. What I do is, I do the following. I do this following manipulation. 2a1 plus 2n minus 2 into d1 divided by 2a2 plus 2n minus 2 into d2. Right? This 2n minus 2 I can write as 2n minus 1 minus 1, 2n minus 1 minus 1, and let me also multiply numerator denominator by 2n minus 1 by 2, 2n minus 1 by 2. You'll see why I have done this. The next step, you'll see that this ratio I could have rewritten as 2n minus 1 by 2 into 2a1 plus 2n minus 1 minus 1 into d1 divided by 2n minus 1 by 2, 2a2 plus 2n minus 1 minus 1 into d2. See, can I do this? Absolutely. What's the numerator? Sum of the first 2n minus 1 terms in the first AP. What is the denominator? Sum of the first 2n minus 1 terms of the second AP, is it not? The numerator is sum of the first 2n minus 1 terms of the first AP. This is sum of the first 2n minus 1 terms of the second AP. Yes or no? All of you are fine with this? Right? So which means now this is as good as for the first AP sum of 2n minus 1 terms, for the second AP sum of the first 2n minus 1 terms. This is what it reduces to. Sum of the first 2n minus 1 terms of first AP divided by sum of the first 2n minus 1 terms of the second AP. Hey, all that you need to do is, this is sum of the n terms, replace n by 2n minus 1. To get this, replace n by 2n minus 1. Right? So in this, replace n by 2n minus 1. If you replace n by 2n minus 1, you end up getting 7. This n is going to be 2n minus 1 plus 1 divided by 4 2n minus 1 plus 17. Yes or no? Which is like 14n minus 6 divided by 8n plus 13. Clear? That's going to be the ratio of the nth term of the first AP to the nth term of the second AP. Are you all fine with this? Time to move to the next problem then. Problem 5. ABC are in AP. We want to show that A squared B plus C, B squared C plus A, and C squared A plus B will be in AP. This is what we want to show. Given that ABC are in AP, A squared B plus C, B squared into C plus A, and C squared into A plus B would be in AP, right? This is what we want to establish. Now, these would be in AP if and only if. IFF means if and only if. A squared B plus C plus ABC, adding ABC to all terms, right? B squared C plus A plus ABC, C squared A plus B plus ABC. If these are in AP, right? If a certain number of terms are in AP, then you can add the same number to each term and the resulting sequence will still be in AP, right? So this would be in AP if these are in AP? Yes or no? These would be in AP if and only if. Let me take A common from this. A. Then what I'm left with is AB plus AC plus BC. I take B common from this. Again, AB plus BC plus CA. I take C common from this. C into AB plus BC plus CA. If these are in AP, yes or no? And now divide by AB plus BC plus CA. So if I, assuming that AB plus BC plus CA is not 0, if I divide by AB plus BC plus CA, this would be true if and only if ABC on dividing by AB plus BC plus CA throughout, right? If ABC are in AP. Right? Yes or no? So, this would be true if this would be true. If and only if means if this is true, this is true. If this is true, this is true. That means it would be a bunch of reversible stages. Right? So from here to here if I can go, then from here to here I could go. That means if I can go from here to here to here to here, then I could have gone from here to here to here to here. Because these are reversible steps. These are reversible steps. This is what it means. Clear? Shall we proceed then? Number 2, 5 part 2. Given again ABC and AP, we want to prove that A into B plus C divided by BC, B into C plus A divided by CA, and C into A plus B divided by AB are in AP. Yeah, and you get the previous problem. But then again, you know, when this problem is given doesn't mean the previous problem will also be given. Right? Yeah, you're right. Absolutely, absolutely. So this would be true if and only if A into B plus C by BC plus 1, B into C plus A by CA plus 1, and C into A plus B by AB plus 1 are in AP. This would be true if these are in AP. And this would be true if and only if, on adding 1, AB plus BC plus CA by BC, AB plus BC plus CA by AC, AB plus BC plus CA by AB are in AP, right? And again I can divide by AB plus BC plus CA. So it's as if these will get cancelled, assuming that they are not 0, right? This would be true if and only if 1 by BC, 1 by CA, 1 by AB are in AP. This would be true if and only if this happens. Now multiply by ABC. So this would be true if and only if, on multiplying by ABC, this will become A, this will become B, this will become C if they are in AP. Yes or no? If A, B, C are in AP. Clear? Sixth problem is about two APs. AP1. There is an AP1 which has the following set of terms: 3, 5, 7, etc. 100 terms. 100 such terms. Right? There is an AP2 which is like terms of the kind 4, 7, 10, 100 such terms. We want to find how many terms are common to the two APs. We have to find how many terms are common to the two APs. Hey, first of all, this is an AP with first term 3 and common difference 2 and number of terms 100. So the 100th term of the first AP, AP1, 100th term of the first AP is going to be what? 3 plus 99, 100 minus 1 into common difference 2. That makes it 201. That's the 100th term of the first AP. Right? For the second AP, what's the 100th term? 100th term of the second AP, say T prime 100. First term 4, common difference 3. Right? So that's going to be 4 plus 99 into common difference 3. So that makes it 297, 270 plus 20, 97, 301. That's the 100th term of the second AP. Right? Yes or no? Now, the first common term of the two APs is 7. The rule of the game is identify the first term common to the two APs by brute force, by observing, that is. Check out a few terms, right? So, the first common term of the two APs is 7. We have to find how many common terms prevail in the two APs. Yes or no? See, I tell you, if first term common is 7. If you don't believe, check out a few numbers. The second common term that you will get would be 13. And then the third common term that you're going to get is 19. These would be the common terms. Reason being, the common difference of this is 2. The common difference of this is 3. Right? This is the first common term of the two APs. Right? Now, the sequence of common terms, I claim, the sequence of common terms between the two APs will have a common difference which would be LCM of the common difference of this and this. If this is D1 equal to 2, this is common difference D2 equal to 3, then the sequence of common terms would be an AP with common difference equal to LCM of D1 and D2. It's more about a concept of LCM than APGP, you know. Find out the first common term. So, you know, after 6 terms, 2 from the first, 3 from the second, after 6 terms, you know, they would be replication of terms. They would be replication of terms. So the sequence of common terms would be an arithmetic progression with common difference equal to LCM of D1 and D2, with LCM of D1 and D2. Now, these are the terms. This is the sequence of common terms. I have to find how many such terms are there. I want to find how many such terms are there, right? Suppose there are n such terms. Suppose there are n such terms. Then what is the nth term of this sequence of common terms? 7 plus n minus 1 into 6. Yes or no? Right? And this cannot exceed 201 if it's a common term. If Tn is the last common term, then it cannot exceed 201, because 201 is the last term of the first AP, 301 is the last term of the second AP. So all common terms would have to be confined to 201. We can't have a common term after 201 because this first AP doesn't have terms after 201. Yes or no? So the last common term has to be less than or equal to 201. Yes or no? The last common term would have to be less than or equal to 201. This is the last common term and this cannot exceed 201. Where n is a natural number. Yes or no? N is a natural number that satisfies this condition. N is a natural number that satisfies this condition. I have to find n. N is a natural number that satisfies this condition. Greatest natural number that satisfies this condition. Yes or no? N is the greatest natural number because I want to find n has to be greatest, isn't it? The last common term. Right? So n is the greatest natural number that satisfies this condition. That means 6 into n minus 1 less than or equal to 194. Such has to be n. That means n minus 1 has to be less than or equal to 97 by 3. 97 by 3. Right? Which is like 32.33. That means n has to be less than or equal to 33.33. So n is the greatest natural number satisfying this condition. What's the value of n? 33. N therefore must be 33. So the number of terms common would be 33. N has to be 33. Number of common terms between the two sequences would have to be 33. Yes or no? All's good? Can I wipe this off? A, B, C, D are positive real numbers. And A plus B plus C plus D is 2. Right? And M is A plus B into C plus D. M is A plus B into C plus D. Now, do you realize that A plus B is, say, one number and C plus D is another number? Then this is the arithmetic mean of these numbers. X plus Y by 2. This is the arithmetic mean of two positive numbers. A plus B is one number and C plus D is another number. This is the arithmetic mean of two positive numbers. And this has to be greater than or equal to the geometric mean of these numbers. A plus B into C plus D? Yes or no? This has to be greater than or equal to the geometric mean of these numbers? Yes or no? AM greater than or equal to GM. But what is this? This is root M. This is root M and this is 1 because A plus B plus C plus D is 2. So this by 2 is going to be 1. Right? So we end up getting 1 greater than or equal to root M. So this gives us M less than or equal to 1. Hey, but since A, B, C, D are positive, so this will be greater than 0 as well. So M will also be greater than 0 because A, B, C, D are all positive. So A plus B will be a positive number, C plus D will be a positive number. So their product will be greater than 0. A plus B into C plus D is going to be a positive number. So M greater than 0, less than or equal to 1. Number 9. A, B, C are 3 terms of an AP. A, B, C are 3 terms of an AP, right? A not equal to B, not equal to C. They are unequal. And they're not consecutive terms. They're not given to be consecutive terms, right? One could be a pth term, one could be a qth term, one could be an rth term. They've never said P, Q, A, B, C are 3 consecutive terms. That's not said, right? We want to show that A minus B by D minus C must be rational. Must be a rational number. What's a rational number? One which could be expressed as ratio of 2 integers, where the denominator is not 0. That's a rational number. Ratio of any 2 integers will be a rational number. So we want to show that A minus B by D minus C is a rational number. Okay. So then the AP that I'm talking of, let's say that AP has its first term L and common difference M. Suppose it has its first term L and common difference M. And say A is the pth term of the AP, B is the qth term of the AP, and C is the rth term of the AP. Right? Clear? Now, what is A? The pth term, which is going to be the first term L plus P minus 1 into common difference M. The pth term, which is A, I have chosen it to be A, is going to be first term L plus P minus 1 into common difference M. First pth term A is going to be first term plus P minus 1 into common difference. Similarly, B is the qth term, which is L plus Q minus 1 into M. D, where is D? There is, this must be B minus C. There is no D here. This must be A minus B by B minus C. I don't see any D here. This must be A minus B by B minus C. Must be a rational number. There is no occurrence of D anywhere. Right? So A minus B by B minus C must be rational. B is this. Similarly, what is C? C is L plus rth term, which is R minus 1 into common difference M. Now, what is A minus B? A minus B is like P minus Q into M, where P, Q are integers, P, Q, R are natural numbers. The pth term, so P has to be a natural number. The qth term, so Q has to be a natural number. The rth term means R has to be a natural number, yes or no? Right? So P, Q, R are all integers. P, Q, R all have to be integers. A minus B is like P minus Q into M. What is B minus C? Divided by B minus C. What is B minus C? Q minus R into M. M gets cancelled. If P, Q, R are all integers, then P minus Q will be an integer. Q minus R will be an integer. Ratio of 2 integers will be a rational number. Isn't it? Integer divided by integer is going to be a rational number, and q is not equal to r. Because they are all distinct terms, q is not equal to r. So this is integer divided by integer, which therefore is a rational number. Which therefore is a rational number. Yes or no? Because you have assumed that they are consecutive terms of the AP. Right? That's why. I never said they are consecutive. That's why it came as 1. Because if they were consecutive, then A minus B will be equal to B minus C. And this ratio will turn out to be 1 if they were consecutive, isn't it? They're not consecutive. Sn be sum of n terms of an AP. AP. Say the first term of the AP is A, and the common difference of the AP be D. That's the common difference of the AP. Clear? We want to find A by D. We want to find A by D, ratio of first term to common difference. Given that sum of n1 and 2 terms, this is divided by sum of n1 terms. Sum of n1 and 2 terms by sum of n1 terms is independent of n1. Given this, we want to find A by D. Given this, we want to be able to find A by D. Now, what is n1 and 2 terms? Sum of n1 and 2 terms. n1 and 2 by 2 into 2a plus n1 and 2 minus 1 into D, right? Divided by sum of n1 terms, which is like n1 by 2, 2a plus n1 minus 1 into D. This is what I get? Yes or no? Sum of n1 and 2 terms, which is this, sum of n1 terms, which is this. It's given that it's independent of n1. What should be A by D in order that this is rendered independent of n1? So first of all, this n1 by 2 from outside will get cancelled. Now, I still have this ratio depending on n1, but they say that this ratio actually does not depend on n1. How should A by D be disposed? How should A by D be disposed so that no matter what value of n1 I take, this expression assumes the same value? That's the problem to be taken care of. You know what I'm saying? Shall I repeat? All that I'm saying is, they want to make this expression independent of n1. That means no matter what n1 I choose, this expression must have the same value. Now, commensurate with that, what should be the ratio A by D that this could happen? What should be the ratio A by D that this could happen? That's the question to be addressed. How should A by D be chosen so that this expression becomes independent of n1? That's the whole idea, right? Now, all that you need to do is sometimes keep your eyes and ears open. Look at the expression with love and affection. Something or the other would emerge that would favor your solution. In this case, be a little brave. Do the following. 2a minus d, write this as 2a minus d plus n1 n2d. Can I do this? 2a minus d plus n1 n2d, the numerator rewritten, that's all, divided by denominator 2a minus d plus n1d. Yes or no? 2a minus d plus n1d. This ratio to be made independent of n1. Hey, I wish, somehow by magic, I could cancel this n1 and this n1. How much I wish that happened. Right? Yes, that can happen. If 2a minus d was 0, then I can cancel this n1 and this n1 and it would become independent of n1. Yes or no? If 2a minus d was 0, then this n1 could have got cancelled with this n1. This expression would become independent of n1. Yes or no? That's a little ordinary observation and inspection. Yes or no? Right? So if 2a minus d is 0, then this is 0, this is 0, this n1 will get cancelled with this n1 and this will be simply n2. The expression would have become independent of n1. Yes or no? That means if 2a minus d is 0, a by d therefore would be half. 2a is d, so a by d would be half. So if a by d was half, this expression would be deemed independent of n1. Yes or no? See, what is it that I was seeking to do? Some mechanism that will cancel this n1 with this n1. Right? Maybe some algebra in some other planet will cause it to happen more easily. But our algebra will not allow an automatic cancellation of this n1 and this n1. But a little observation, that means causing this to be 0, then this goes into oblivion. I'm left with n1 n2d divided by n1d. n1 n1 getting cancelled and it's only n2. That means then this expression will become independent of n1 if 2a minus d was 0. That means if a by d was half. That is what we were modeling the problem for. Find a by d so that this expression becomes independent of n1. A by d is half. 2a is d, a by d is half. Yes or no? Got me? Sorry. That n2 shouldn't have gone anywhere. Let me restore that poor n2. It was not harming us, so n2 squared. Right? Sorry. It was, I got swayed away, and in the process of going from this step to this step, I ate away this n2. But thanks for pointing that out. Right? That n2 of course prevails, and this will become n2 squared. That's all. Still independent of n1. The condition prevails. Right? Yes or no? So we have a set of terms tr, t1, t2, t3, tn, set of terms tr's, t1, t2, t3, tn, such that summation tr, that means t1 plus t2 plus t3 plus tn, are equal to 1 to n, is n by 8 into n plus 1 into n plus 2 into n plus 3. We want to be able to deal with summation 1 by tr, r equal to 1 to n. That means this is like 1 by t1 plus 1 by t2 plus 1 by t3, etc. Right? Given that t1 plus t2 plus t3 plus tn is this, we want to find the value of 1 by t1 plus 1 by t2 plus 1 by t3 plus 1 by tn. Right? Now, first of all, given this, sum of the tr terms, can I find the nth term? Can I? Yes.
Summation till n term and summation till n minus 1 term.
Yes. The nth term, this is sum up to n terms. Yes or no? This is sum up to n terms. The nth term is going to be sum up to n terms minus sum up to n minus 1 terms. Yes or no? Right? Sum up to n terms is this. Sum up to n minus terms can be obtained by replacing n by n minus 1. Right. So this is Sn. Replace n by n minus 1, you get Sn minus 1. And the difference between sum up to n terms and sum up to n minus 1 terms is going to give us the nth term. Right. sum up to n terms is going to be n by 8 into n plus 1 into n plus 2 into n plus 3 minus, replace n by n minus 1. So n minus 1 by 8 into n plus 1 into n plus 2. This is what we get, right? This will give me the nth term of the sequence, Tn, right? So the general member of the sequence will be available to us. Let's simplify matters here, right? This then, if I take, say, n into n plus 1 into n plus 2 by 8 common, right? N into n plus 1 into n plus 2 by 8 common, then I'll be left with n plus 1 minus n minus 1. That makes it 2. Yes or no? I'm sorry, n plus 3 minus n minus 1 by 8. N plus 3 minus n minus 1 by 8, which is 4 by 8. By 8, it'll 4 by 8, that will become 2. Don't get so finicky about this. Let me write something on the board, before you utter so much. N plus 3 minus n minus 1 by 8. I'm saying I'm just doing a calculation for you. That's going to be 4 by 8. It'll become 2. That's all that I'm saying. N plus 3 minus n minus 1 is 4. That divided by 8 is going to give me 2 in the denominator, right? So, by 2. Right? So then, Tn is known to us. So 1 by Tn is going to be 2 divided by n into n plus 1 into n plus 2. Right? So the general term of the sequence, Tr, or rather 1 by Tr, replace n by r. Replace n by r. So that's going to be 2 divided by n, or rather r, into r plus 1 into r plus 2. That's going to be 1 by Tr. That's going to be 1 by Tr, yes or no? Yes, sir. Now, one by Tr is 2 divided by r into r plus 1 into r plus 2. We want to plug in r equal to 1, 2, 3, etc. up to n and add it up. Now, if you recall from our previous session, this should be expressed as a difference of two sequences, right? What I do is, I write the numerator as last term minus first term, r plus 2 minus r. That's how I write the numerator. So this is like r plus 2 minus r divided by r into r plus 1 into r plus 2. How about it? Right? And now when I divide, this turns out to be 1 by r into r plus 1 minus 1 by r plus 1 into r plus 2. Yes or no? Now, this and this, are they related? This could be obtained from this by replacing r by r plus 1. So if 1 by this is chosen as Vr, then 1 by this would be looked upon as Vr plus 1. Yes or no? Right? So if Vr is 1 by r into r plus 1, right? Then Vr plus 1 would be 1 by r plus 1 into r plus 2. 1 by r plus 1 into r plus 2. Right? Now, so 1 by TR is VR minus VR plus 1. A telescopic sequence would emerge. I plug in R equal to 1, 2, 3 up to N and add them vertically, right? So if I plug in R equal to 1, then I end up getting 1 by T1 equals V1 minus V2, right? Plug in R equal to 2, 1 by T2 is V2 minus V3. 1 by Tn is Vn minus Vn plus 1, right? We need the value of 1 by T1 plus 1 by T2 plus 1 by T3 plus 1 by Tn, right? Let me add them. So if I add them, realize that there is a cancellation of this kind that takes place. You're left with two terms, V1 and Vn plus 1. So if I add, then the left hand side is going to be summation 1 by Tr, R equal to 1 to N equals V1 minus Vn plus 1. How do you obtain V1? Put R equal to 1. How do you obtain Vn plus 1? Put R equal to N plus 1. So V1 turns out to be 1 by 2. Vn plus 1 turns out to be 1 by N plus 1 into N plus 2. Yes or no? So that's summation 1 by Tr half minus this. Clear? Let's look at, so this was 11 part 1. This was 11 part 1. Let's look at 11 part 2. Can I wipe this off? Can I wipe this off? Ah, whose was that? Huh? Yeah. Let's just finish this. Yeah. It is. 11 part 2. What we'll do is every time you want to come down here, we'll stand by and we'll ask you to solve the problem. So then, 11 part 2, we want to find the value of this product 1 plus 3 to power minus 1 into 1 plus 3 to power minus 2 into 1 plus 3 to power minus 4, going this way, 1 plus 3 to power minus 2 to power n, right? 2 to power n. We want to show that this is equal to 3 by 2 into 1 minus 3 to power minus 2 to power n plus 1. This is what we want to show. Any ideas? Yes?
Multiply both sides with minus 1 by 2.
Absolutely. When you multiply this with 1 minus 3 to power minus 1, it will become 1 minus 3 to power minus 2, a squared minus b squared. And then 1 minus 3 to power minus 2 with this would give me 1 minus 3 to power minus 4. And 1 minus 3 to power minus 4 with this would give me 1 minus 3 to power minus 8. And terms keep getting absorbed as you move from left to right. 1 minus 3 to power minus 1 therefore serves as a catalyst, right? It initiates the chain and takes you to the end of the chain, right? So what we do is, very good, Raj. 1 minus 3 to power minus 1 into P equals 1 minus 3 to power minus 1 into 1 minus 3 to power minus 2 1 plus into 1 plus, sorry, 1 plus 3 to power minus 1, 1 plus 3 to power minus 2, 4, n. A plus b into a minus b, a squared minus b squared. So 1 minus 3 to power minus 2 into 1 plus 3 to power minus 2, 1 plus 3 to power minus 4, 1 plus 3 to power minus 8, 1 plus 3 to power minus 2 to power n. Right? And again, a plus b into a minus b, a squared minus b squared. So this would be like 1 minus 3 to power minus 4 into 1 minus 1 plus 3 to power minus 4. One plus 3 to power minus 2 to power n. Eventually, so this will become 1 minus 3 to power minus 8 into 1 plus 3 to power minus 8, 3 to power minus 2 to power 4, and so on and so forth. Eventually, if you keep doing this, then the term before this, after having absorbed everything, would be 1 minus 3 to power minus 2 to power n into 1 plus 3 to power minus 2 to power n. How about it? So this is like a minus b into a plus b, which is a squared minus b squared, which then gets reduced to 1 minus 3 to power minus 2 to power n whole squared, means into 2. 1 minus 3 to power minus 2 to power n plus 1. But what is this? This is 2/3 p. All of this is 2/3 p. This is 2/3 p. So p is going to be 3 by 2 of this. P is going to be, see, this is 2/3, right? 3 by 2 into this. Clear? All that I have done here is multiplied throughout by 1 minus 3 to power minus 1. So a minus b into a plus b, a squared minus b squared. This becomes 1 minus 3 to power minus 2 into 1 plus 3 to power minus 2. That makes it 1 minus 3 to power minus 4 into 1 plus 3 to power minus 4, which makes it 1 minus 3 to power minus 8, etc. Eventually, keep absorbing terms like this. Then the term that would appear just before this would be 1 minus 3 to power minus 2 to power n. So a minus b into a plus b, which is a squared minus b squared, and so on and so forth. So that's all 2/3 p. The required p is going to be 3 by 2 of this. Can I wipe this off? Part 3. One by root 3 plus root 1 plus 1 by root 5 plus root 3 up to n terms, right? Clear? The nth term here, by the way, the nth term here is going to be, please check for yourself, root 2n plus 1 minus root 2n minus 1. See, n equal to 1 will give me root 3 minus root 1. N equal to 2 will give me root 5. I'm sorry, plus root 3, and so on and so forth. So the nth term is going to be this, right? All that you need to do here is absolutely. I'm very pleased with the way you're going. Despite the fact that you are so fun loving, you do your job very well. Very good. So S is, you rationalize each term. So root 3 minus root 1 divided by 2, right? Plus root 5 minus root 3 divided by 2. Root 7 minus root 5 divided by 2. Root 2n plus 1 minus root 2n minus 1 divided by 2, and so on and so forth. Now you should be able to tell me, fairly simple, half could be taken common, and see how cancellation occurs. See, root 3 will get cancelled with root 3 here. Root 5 will get cancelled with root 5 here, right? This term would have got cancelled with the first term of the previous bracket. This will remain unattended. Root 1 will remain unattended. Therefore, the only set of terms here would be root 2n plus 1 minus 1. Yes or no? All of the terms will get cancelled, yes or no? See, the minus is going to get cancelled with the previous bracket. So this minus would have got cancelled with the first term of the previous bracket. This, if at all, would have got cancelled with the second term of the next bracket, which is not there. So this will remain unattended. This one will remain unattended, and everything else would be taken care of, right? This would be the required sum. All's good? Shall we proceed? You got delayed today, Shopurna? Rains? Okay. So then you were early. Come on, you can't be bothering Shopurna all the time, Yeah. You are just having fun at his expense, which is all right. He doesn't mind it either, right? You do? No, he's a little mild about it. Okay. So 11 part 4. He's a good fellow except for certain things that he utters once in a while. All's good about him. So enlightening. So in any case, the next problem is about 1 by 1 squared plus 1 by 2 squared plus 1 by 3 squared adding up to pi squared by 6. That's given. You may not be able to prove this result now. If I explain it to you, you may or may not be able to even understand why so. But this, let's say, assume this is given. Assume that this is given. You want to be able to find 1 by 1 squared plus 1 by 3 squared plus 1 by 5 squared up to infinity. I'm sure he has an answer. Where? No, if I'm not writing anything means it goes on forever. Men may come and men may go. Right? So, given this, and I'm sure Raj will have something too.
We take this series out and we take 4 common and we get the original.
Very good. Very good. So, precisely so, what we do is we sieve the terms out from this series. In this series, we take a set of terms like the ones that we need, 1 by 1 squared plus 1 by 3 squared plus 1 by 5 squared, right? And then the ones that are squares of even numbers, 1 by 2 squared plus 1 by 4 squared plus up to infinity. That's equal to pi squared by 6. Right? Right? This is the sum S that we need. Refer to this as S. Right? The one that we are seeking. Plus. What I do is I take 1 by 2 squared common from this. So if I took 1 by 2 squared out of this, then what I am left with is 1 plus 1 by 2 squared plus 1 by 3 squared up to infinity. That's equal to pi squared by 6. Clear? The next term would be 1 by 6 squared. So if I took 2 squared common from that, I get 3 squared. Then the one after that would be 1 by 8 squared. If I took 2 squared common, so on and so forth. Right? Hey, but this is the original mother sequence, which is pi squared by 6. Yes or no? 1 plus 1 by 2 squared plus 1 by 3 squared up to infinity is pi squared by 6. So this will become pi squared by 24. This will become pi squared by 24. And if this becomes pi squared by 24, then we have pi squared by 6 minus pi squared by 24. That's going to be S, right? So S is going to be pi squared by 6 into 1 minus 1 by 4, which is like a pi squared by 6 into 3 by 4, which is pi squared by 8, which is pi squared by 8 is what we get out of this. Right?
How do we obtain the above result? This one, how do we do it?
Okay, let me do it for you. Only thing is, the disclaimer is you may or may not understand everything, but let me still solve it for you. Let me show you how to get this. Okay? Let me tell you, even if you don't understand everything that I'm going to be communicating, refer to what I'm going to do now some other time. Later part of class 11 you will understand, but if you understand it now also, I don't have a problem. Okay? Okay, let me then do it, go out of the box and do this for you. Alright? Okay. See, sin x when x is in radians, sin x when x is in radians can be expressed as an infinite number of terms, x minus x cubed by 3 factorial plus x power 5. You know factorial notation, right? All odd terms. And so on and so forth. This is a standard result. If you want, I will prove this also for you. But let me use this right now, and if you insist, I'll tell you why this is also true. Okay? Sin x by x sin x by x is like a 1 minus x squared by 3 factorial plus x power 4 by 5 factorial minus x power 6 by 7 factorial and so on and so forth. Do you understand this? Given that this is true, do you understand this? Okay. Now, See, sin x becomes 0 at what values of x? For what values of x equal to plus minus pi, plus minus 2 pi, plus minus 3 pi. These are the values of x for which sin x becomes 0. Yes or no? Also x equal to 0. Also x equal to 0. Yes or no? Also x equal to 0. However, sin x by x will become 0 not at x equal to 0 because it will be undefined at x equal to 0. So when I talk of sin x by x, then sin x by x will not become 0 at x equal to 0. It will become 0 when x is plus minus pi, x is plus minus 2 pi, x is plus minus 3 pi, and so on and so forth. How about it? Right? That means this, if I have to factorize this expression, then I claim that its factors would be 1 minus x squared by pi squared. I'll tell you why. 1 minus x squared by 4 pi squared. 1 minus x squared by 9 pi squared. 1 minus x squared by 16 pi squared. And so on and so forth. I claim that sin x by x, why? I'll tell you why. See, sin x by x will become 0 when this is 0, and this will give me x equal to plus minus pi. Or will become 0 when this is 0. This will give me x equal to plus minus 2 pi. Isn't it? If this is 0, I'll get x equal to plus minus 2 pi. Or if this is 0, I'll get x equal to plus minus 3 pi. Yes, this will become 0 at x equal to plus minus 4 pi. Yes or no? That means this must be the factorization of this. These must be the factors of this expression up to infinity. Yes or no? Right?
These two are true only if sin x by x is 0. How can we be sure?
When I factorize, if px is 0 at x equal to a, then x minus a must be a factor of px. That's remainder theorem, right? So if sin x by x is 0 at x equal to alpha, then x minus alpha must be a factor. That's all. That's why you find roots, so that you can find factors, right? I mean, x squared minus 5x plus 6 is becoming 0 at x equal to 3. So x minus 3 will be a factor. It's becoming 0 at x equal to 2. So x minus 2 would be a factor, right? Doesn't mean that x is 3 or x is 2. It's just that since x minus 3 is a factor, it will cause the expression to be 0. Right? Raj?
How we derive sin x the series?
Huh?
We can also, can we use this one?
No. To derive this, something more fundamental. If you are keen, I will tell you right after having established this. I'll tell you how to obtain this also, if you so want. But let me finish this first, right? So now, this, when you factorize something, do you create an equation or an identity? Identity. So this expression is identical to this expression. That means coefficient of x power 0 here must be equal to coefficient of x power 0 here. Coefficient of x power 1 here must be equal to coefficient of x power 1 here. Coefficient of x square here must be equal to coefficient of x square there. Coefficient of x cubed here must be equal to coefficient of x cubed there. If two polynomials are identical, then coefficients of equal powers of x in both the polynomials must be the same. You know what I'm saying? Now, what's the coefficient of x square on the left hand side? Minus 1 by 6. Minus 1 by 6 is the coefficient of x square on the left hand side, right? So, minus 1 by 6. Now, coefficient of x square on the right hand side. How do you get the coefficient of x square? See, minus x square by pi squared into 1 into 1 into 1. Right? That's one way. See, how do I obtain the x square kind of terms from the right hand side? See, minus x squared by pi squared. Just look at how I could get, if I multiply this out, how would I filter out the x square terms? Minus x square by pi squared into 1 into 1 into 1 into 1. That's one term containing x square. Or look at this minus x squared by 4 pi squared. The second x squared by 4 pi squared into 1 into 1 into 1 into 1 into 1. Yes or no? And then minus x squared by 9 pi squared into 1 into 1 into 1 into 1 into 1 into 1, right? And so on and so forth. So then, what's the coefficient of x squared on the right hand side? Minus 1 by pi squared, minus 1 by 4 pi squared, minus 1 by 9 pi squared, minus 1 by 16 pi squared would be the coefficient of x squared on the right hand side. What's the coefficient of x squared on the left hand side? Minus 1 by 6. Equate the coefficient of x squared on the left hand side with the coefficient of x squared on the right hand side. Then this is what transpires. If you did that, then coefficient of x square on the left hand side is minus 1 by 3 factorial, means minus 1 by 6. Coefficient of x square on the right hand side is minus 1 by pi squared, minus 1 by 4 pi squared, minus 1 by 9 pi squared, minus 1 by 16 pi squared, and so on and so forth. Yes or no? Pi squared by 6, therefore, is going to be 1 plus 1 by 2 squared plus 1 by 3 squared plus 1 by 4 squared, and so on and so forth. If you have understood this, it's all right. If you have not understood this, then also it's all right for the time being. But this is what you do, right? Oh, sin x series, okay. All right. Take a little detour. What's there? Sin x, hope you understand what I'm going to be saying here, is going to be expressed as some, we want to write this as some a naught x plus a1x squared as a2x cubed plus a3x power 4 up to infinity. This is what we want to do with sin x. We want to be able to express sin x as a polynomial. So rather, sorry, a naught plus a1x plus a2x squared plus a3x cubed, and so on and so forth. We want to write sin x as a polynomial of infinite number of terms. Right? Now, how does one do that? The question is how one could do this. When you write this in this manner, you're actually writing an identity. This is an identity. It's true for all values of x. So what you do is, first of all, plug in x equal to 0 on both sides. Plug in x equal to 0 on both sides. So these terms will go into oblivion. You get a naught equal to sine 0, which is 0. A naught equal to 0 is what you get. Now that you know a naught, it would be a good idea to wither away a naught and deal with the rest. Be a little worldly wise now. A naught ka kaam ho gaya. Let's throw a naught out now. How to throw a naught out? A naught is a constant. So if you differentiate with respect to x, then the derivative of a naught would be 0 because a naught is a constant. So a naught gets bundled away, right? So let me differentiate both sides with respect to x. So when I differentiate both sides with respect to x, then I get another identity, cos x equal to a1 plus 2a2x plus 3a3x squared, and so on and so forth. Yes or no? Right? Now again plug in x equal to 0. If you again plug in x equal to 0, then these terms would vanish, leaving you with a1. a1 equal to cos 0, which would be 1. a1 equal to cos 0, which is 1. So this was 0, a0 was 0, a1 turned out to be 1. So the first term is x. Like I had written earlier, sin x equal to x minus x cubed by 3 factorial, and so you would expect a2 to be 0. What you do is, now that we know a1, we want to throw a1 out. How do I do that? Differentiate one more time with respect to x. So if I differentiate one more time with respect to x, what do I get for sine x? Minus sine x is 2a2 plus 3 into 2 a3 into x and so on and so forth. This is what I get. Plug in x equal to 0 again. You get the other terms contain x will vanish anyways. Plug in x equal to 0. You get a2 equal to 0 again. Isn't it? Because these terms would vanish. The rest of the terms contain x. This one is deprived of x. So plug in x equal to 0 again. So 0 equal to 2a2 plus 0. So a2 turns out to be 0. So plug in x equal to 0 again. a2 is 0. Right? Now differentiate again with respect to x. Yes or no? If you differentiate again with respect to x, you have like a minus cos x plus equals 3 into 2 into a3 plus other terms that will contain x. And plug in x equal to 0 again. These terms, bless you, containing x will vanish, leaving you with a3. This is 3 factorial. 3 into 2 into 1 is 3 factorial. a3 turns out to be minus 1 by 3 factorial. If you plug in x equal to 0 again, minus 1 by 3 factorial, yes or no? So a3 turns out to be minus 1 by 3 factorial. You will get a4 as 0. You will get a5 as 1 by 5 factorial if you keep doing this. That's how you expand sin x as a set of infinite number of terms. This is what you do, right? Let's get back to more mundane stuff now. Huh? More comprehensible? Yes. For cos x, yes, you could write cos x as a naught. In fact, what will turn out is, if you write cos x, will then turn out to be 1 minus x square by 2 factorial plus x power 4 by 4 factorial minus x power 6 by 6 factorial and so on and so forth will be the expansion for cos x. And do you realize only even powers of x appear here? So if you replace x by minus x, cos, it will turn out to be the same as cos x. That's why cos minus x is the same as cos x. Sin x has all odd powers of x. That's why if you replace x by minus x, sin minus x turns out to be minus sin x because of the occurrence of odd powers of x. You know what I'm saying? Yes, no, and tan x has some limitations. So in any case, the sin x and cos x you understand. You could write cos x as a naught plus a1x plus a2x squared, etc. Put x equal to 0, differentiate. Put x equal to 0 and again differentiate. And so on and so forth. You can successively obtain the various coefficients this way. Alright? Okay. Let's move to problem number 12. Part 1. We want to find the summation 1 by 1 plus 1 squared plus 1 to power 4 plus 2 by 1 plus 2 squared plus 2 to power 4 up to n terms. We want to find the sum up to n terms of this. So designate the rth term first, right? The rth term is going to be r divided by 1 plus r squared plus r to power 4. Yes or no? Clear? See, 1, 2, 3, the rth term will have r, and then 1 plus r squared plus r to power 4, 1 plus r squared plus r to power 4, and so on and so forth. Right? And look at this denominator, r to power 4 plus r squared plus 1. This could be written as r squared plus 1 whole squared minus r squared. Yes or no? Isn't it? Which is like r squared plus r plus 1 into r squared minus r plus 1. Isn't it? A squared minus b squared, a plus b into a minus b. This is what happens. Which means now this expression TR could be written as r divided by r squared plus r plus 1 into r squared minus r plus 1. Yes or no? Now, I could write this as 1 by r squared minus r plus 1 minus 1 by r squared plus r plus 1, half of this. See if it makes sense to you. See? Because see, r squared plus r plus 1 minus r squared minus r plus 1 will give you 2 in the numerator, 2r in the numerator. R was already there, I balance it with the 2. The excess 2 that I get in the numerator is balanced. Yes or no? And not only that. Do you have a remark here? Anyone? Raj? See, look at this. We are as 1 by r squared minus r plus 1, for example, or rather minus r plus 1, r squared minus r plus 1. Suppose this is VR. What would this be? No, see, r is an integer, natural number only. So if VR is defined, V minus R will not be defined. In this case, R are all natural numbers, right? So there is nothing like V minus R defined for this case. See, in this expression, R squared minus R plus 1, if you replace R by R plus 1, what would you get? R plus 1 whole squared minus R plus 1 plus 1. If you replace R by R plus 1, which is like R squared 2R minus R plus R plus 1 is what you get. Yes or no? That means in this expression, if you replace R by R plus 1, you get this. So if this is chosen as VR, what would this be? VR plus 1. Right? So which means TR is going to be half of VR minus VR plus 1. VR minus VR plus 1. If this is VR, then this is going to be VR plus 1. Right? And now a telescope would emerge. T1 is going to be half of V1 minus V2. T2 is going to be half of V2 minus V3, R equal to 2, put R equal to 3. Going this way, R equal to N. So T1 plus T2 plus T3 plus Tn is the required sum, and that's going to be half of, see how the terms get cancelled? V1 and Vn plus 1 are the two leftover terms. V1 is plug in R equal to 1, Vn plus 1 would be plug in R equal to n plus 1 in this. Yes or no? So that will give you the required sum S. I'm not adding all the halves. I'm taking half common from the whole thing. Right? Up to n terms. Let me designate the rth term of the sequence first, right? The rth term of the sequence is going to be, see, r squared into r plus 1 whole squared, that's going to be the denominator of the rth term. 1 squared, 2 squared, 3 squared. So rth will be r squared into 1 r plus 1 squared. And do you realize the numerators are 4 minus 1, 3, 9 minus 4, 5, 4 squared minus 3 squared, 7. So this is going to be r plus 1 whole squared minus r squared. Yes or no? Clear? Now I divide. So if I divide, I end up getting 1 by r squared minus 1 by r plus 1 whole squared. That's TR. A telescope would emerge, because if this is VR, this would be V r plus 1, right? So if this is VR, then this is deemed VR plus 1. Clear? So then the rth term is VR minus VR plus 1. Plug in R equal to 1, V1 minus V2, R equal to 2, V2 minus V3. Going this way, R equal to N, Vn minus Vn plus 1, right? And all that I need is T1 plus T2 plus T3 plus Tn. Vertically I add, and there is a cancellation of terms of this kind, leaving you with V1 and Vn plus 1. So summation of all the TRs, which is the required sum, R equal to 1 to n, is going to give me V1 minus Vn plus 1. V1 is obtained by plugging R equal to 1. So 1 by 1 square, right? Plug in R equal to n plus 1, you get V n plus 1. So minus 1 by n plus 1 whole square. That's the required summation. Got it? Shall we proceed? One plus 4 by 5 plus 7 by 10 plus 10 by 5 cubed, etc. We need to add. Hey, do you see a property of this terms? See, yes, 1, 4, 7, 10, etc. are in arithmetic progression with common difference 3. Whereas 5 to power 0, 5 to power 1, 5 squared, 1 by, rather 1, 1 by 5, 1 by 5 squared, 1 by 5 cubed are in GP with common ratio 1 by 5. With common ratio 1 by 5. See, 1 by 5, 1 by 5 squared, 1 by 5 cube, common ratio would be 1 by 5. So, this is neither an arithmetic progression nor a geometric progression. If you isolate terms, part of the terms are in AP, and then the other ones are in GP. This is called an arithmetico-geometric progression. This is an arithmetico-geometric progression. This is an arithmetico-geometric series. Now, which is like in a very general sense. Let me deal with it in a more general sense. Okay. Say I have a summation of this kind. A term A, and then A plus D into R, then A plus 2D into R squared, A plus 3D into R cube, A plus n minus 1 into D, the nth term of the AP series, into R to power n minus 1. Yes or no? See, A plus D, A plus 2D, A plus 3D, A plus n minus 1 into D, that constitutes an arithmetic progression, whereas R to power 0, R to power 1, R squared, R cubed, R to power n minus 1 will constitute a GP series, right? So this is typically, so this is of the same form. 1, 4, 7, 10 are like A plus D, A plus 2D, etc. AP, and 1 by 5, 1 by 5 squared, 1 by 5 cubed, etc. are like 1 R squared, R cubed, etc. with common ratio R equal to 1 by 5, right? So if I can deal with this, I can deal with this, right? Let me get general about this. Now, I just need a little more room, so I'll shift the whole thing. Let me remove the clutter and rewrite this so that there is ample space for me to represent. A plus D into R, A plus 2D into R squared, A plus 3D into R cube, going this way. We have A plus n minus 1 into D into R to power n minus 1. The term prior to this would have been A plus D less than this, n minus 2 into D, R to power n minus 2 would have been the term just prior to this, yes or no? I want to add all of this. The manner in which you want to deal with an arithmetico-geometric series, the manner in which you want to deal with an arithmetico-geometric series is, look at the GP part of it, 1, R squared, R cubed, etc. Look at the GP part of it. It has common ratio R. What you do is multiply the entire series with R. Multiply S with R. So now if you multiply A with R, what will it become? AR. So AR, write it below the R term. Shift the whole thing 1 unit to the right. Multiply with R and shift the whole thing 1 unit to the right. So A when multiplied with R will become AR. But instead of writing it below this, write it below this. Right? AR. This when multiplied with R will become A plus D into R squared. Write it below this. To make the terms commensurate, similar. Right? When you multiply this with R, this will become A plus 2D into R cubed. Write it below this. and going this way. Eventually, when you multiply this with r, this will become a plus n minus 2 into d, r to power n minus 1. Write it below this. Right? The whole thing has got shifted by 1 unit to the right. So this will become a plus n minus 2 into d into r to power n minus 1. Now when you multiply this with r, this will become a plus n minus 1 into d into r to power n, right? So plus yes or no? So there is this isolated term, the other terms are paired. The other terms have got paired, right? This then becomes isolated, right? Now what I do is I subtract. If I subtract, I get like a 1 minus r into s. Up to this, how many terms are there? How many pairs will be there? N pairs. Up to this, there will be n pairs. And this would be the unattended term, right? No, this with 0, say, for example. So, this will become a plus, this will become d into r when I subtract. This will become like a d into r squared. This will become like a d into r cubed. This will become like a d into r to power n minus 1. Right? And minus this term is a lone term, minus a plus n minus 1 into d into r to power n. Clear? How many terms are there in all from here to there? N terms. If I isolate this, then how many terms will be there? N minus 1 terms, right? So this would be like a plus, add these. These are n minus 1 in numbers. I take d common from these, right? So first term r, common ratio r, number of terms, n minus 1. So that's going to be a into common ratio r to the power number of terms n minus 1 minus 1 divided by r minus 1. A into r to power number of terms minus 1 divided by r minus 1. That's going to be the summation of this portion, minus a plus n minus 1 into d r to power n. If I subtract this minus this, so this will become minus, isn't it? S therefore would be this whole thing divided by 1 minus r. S would be known to you. Obviously, you don't want to remember this as a formula. Remember this only as a technique, right? Don't get the zillions of terabytes that you have in your head get consumed to remember formulas. Leaves a large part of it available for processing as a RAM. All formulas are easy, but then you know what is the big fun? In any case, I'll tell you, if there are teachers like me, they would obviously not remember these formulas. So if you write down a formula, I'll get a formula like this and solve a problem, you know, I'll take it with a pinch of salt. And these are not supposed to be standard results. These are supposed to be standard techniques, but not standard formulas. Okay? So if you still think you have a few extra 1,000 terabytes to be used for remembering all of this, I don't have a problem. I am okay with it. That was only my suggestion. But you understand this, right? So the problem that is there, the next problem, which is exactly this, you know, that 1, 4, 7, etc. is an AP series. It's like a plus D, etc. A you know, D you know. And 1 by 5, 1 by 5 squared, 1 by 5 cubed is a GP series with common ratio 1 by 5, right? You can deal with this. Is that all? Is that all right? 12 part 4. What do we do? Ideas? What do we do with this?
Sir, can we try equating this with the second degree volume and third degree volume and try solving? I'm saying you assume that nth term to be a n square plus
How do you, why do you think it's going to be a quadratic? Why not a cubic?
we have 5 terms, so we assume to be 5 degree volume. It cannot be more than that.
No, that's not true. That's not true.
No, if it is more than that, then there is uncertainty in what it is.
No, the point is there is still some sequencing here. Sometimes I'll tell you, you have to go down to the deep from whence you sprung. This sheet is titled ab initio. Sometimes you have to, for a little while, forget all the things that you have learned. Okay? Say, go back to class 7. Alright? Go back to class 7. Or class 6. A smart class 6 student, what would you do? The difference of the difference is going to be a GP series. Okay, now I say just inspect. You actually,
If you subtract minus 1, we get, no, it's like 4, 18, 63 and 210, which is 64. 64, which is more
210,
it is
18.
better than this.
I'm not asking you to find approximately the sum. Right? As engineers, although I'll tell you, we are, you know, typical engineers where we don't want to behave like, you know, theoretical scientists who would want the right answer till the 20th place of decimal, spend an extra few decades doing that and be of no consequence. Rather, approximate as and when possible, wherever likely, and be okay till the second place of decimal, because the situation that warrants that answer is one where, you know, beyond the second place of decimal, it may not be even perceptible to the 5 senses, so it will not even make sense. So as engineers, you know, that's a good thing, but then for these problems, you know, which are deterministic, we could just be a little inspective. Okay. See, this is inspection, but you could try other things also. As he said, the difference of the difference. But this is like 3 minus 2. Yes or no? 3 squared minus 2 squared. 3 cube minus 2 cube. Pandey ji! Yes or no? So the rth member of the sequence is going to be 3 to the power r minus 2 to the power r. That's going to be the rth member. Summation tr, r equal to 1 to n, is going to be summation 3 to the power r equal to 1 to n, minus summation 2 to power r equal to 1 to n? Yes or no? What is this? How do you sum up 3 to the power r? Hey, tell me. What sequence is this? It's a GP series with first term 3, common ratio 3. Yes or no? 3, 3 squared, 3 cubed, etc. This is a GP series with first term 2, common ratio 2. Number of terms n. Right? So this is first term 3, 3 to the power n minus 1 by 3 minus 1. That's a required summation. Java nahi baba. No, no, no. Part 5. We want to find this sum. S equal to what would you do? You would first earmark the rth term, the general member of the sequence, right? What is TR? 1, R plus 1, R plus 2. This would be R plus 3. Yes or no? Clear? Next, Raj. Ideas brewing in you? Pandeyji, you're giving some ideas. Ek minute. Pandeyji has spoken after a long time. Any Pandeyji?
Divide r by r into r plus 1 into r plus 2 and 3 by r plus r. Sorry. क्या बोल?
No, वहीं से बोलो. Okay, I have understood what you are saying. If I go wrong, tell me. This is what you said first, right?
No, this whole 3 outside.
Whole 3 outside.
Yes. Sir,
Okay, that'll also work. Yes, you have something. R plus 2 plus R plus 1 minus R. Okay, I mean that's also acceptable. See, all these are acceptable variations. You are saying, write this as, no, all these will work. I'll tell you, all roads will lead to Rome here. R plus 2 plus R plus 1 minus R. So then there was originally an R plus 2 here, so there is 3 here. So we'll have to divide by 3 and multiply by 2. This is also fine. There is no issue with this, because then all of them actually a step here or a step there, which is all right. So we get a 3 here. We want to divide by 3 because we need a 2 here, right? There was an R plus 2 there, or rather it was R plus 3 only. It was R plus 3 only originally. So we don't have to do anything, right? So we could do this, right? And now if I divide, this would be like 1 by R into R plus 1 minus 1 by, if I divide this, R into R plus 2 minus 1 by R plus 1 into R plus 2. Yes or no? Plus, right. Clear? Now, this TR could be written as 1 by R into R plus 1 minus 1 by R plus 1 into R plus 2. For reasons not difficult to fathom, I combine these two, because if this is VR, this is VR. r plus 1, and this 1 by r plus 2 could be written as 1 by r minus 1 by r plus 2, half of this 1, isn't it? 1 by r minus 1 by r plus 2, half of that, right? So if this is some q of r, this will be q of r plus 2. Yes or no? You know what I'm saying? Right? So this is fine. What Raj you were saying is also fine. They're all equally good. There is no major difference. So, which is like, if this is VR, then what would this be? VR plus 1. Right? So then TR could be written as VR minus VR plus 1. This was VR, so this would become VR plus 1. And if this is QR, this is QR plus 2. If this is QR, then this would be QR plus 2. Clear? Right? So plus half of now I would leave the rest to you. Plug in r equal to 1, 2, 3, n. In this case, terms would get cancelled from alternate brackets. QR plus 2, and so on and so forth. That means Q1 minus Q3, Q2 minus Q4, Q3 minus Q5, Q4 minus Q6, and so on and so forth. In this case, they would get cancelled like it did in a conventional telescope, right? You know how to deal with this. So plug in r equal to 1, 2, 3, n and figure out what happens. Right? All's good? So, problem number 13, part 1. These AIs are greater than 0. Pi AI means what? Product of all the AIs. I equal to 1 to n is given to be 1. That means A1 into A2 into A3 into AN, pi means product of the terms of the kind AI. A1 into A2 into A3 into AN is 1. We want to show 1 plus A1 into 1 plus A2 into 1 plus AN bigger than or equal to 2 to the power n. This is what we want to establish. Clear? Very simple. 1 plus A1 by 1. Arithmetic mean of these numbers? Greater than or equal to geometric mean? Root A1, 1 into A1? Yes or no? Right? AM greater than or equal to GM, 1 and A1 are both positive. Similarly, 1 plus A2 by A2 greater than or equal to root 1 into A2, root A2. 1 plus AN by 2 greater than or equal to root AN. Multiply it out. So 1 plus A1 into 1 plus A2 into 1 plus AN divided by 2 to the power n bigger than or equal to root A1 A2 AN. But A1 A2 AN is 1, so this will be 1. So this will be greater than or equal to 2 to the power n, etc. Got it? Got this? Okay. Let's look at the next problem. Sounds good, right? Yes. There's actually nothing difficult about it, right? Part 2. N is a natural number. We want to show that 2 to the power n minus 1, or rather 2 to the power n, is bigger than 1 plus n into root 2 to the power n minus 1. Yes or no? Now, this is as if we want to establish that 2 to the power n minus 1 by 2 minus 1 divided by n is bigger than 2 to the power n minus 1 by 2. Yes or no? That's a equivalent problem to address. That's an equivalent problem to address, right? 2 to the power n minus 1 by 2 minus 1 is what? It's a GP series of n terms. First term 1, common ratio 2. Yes or no? This is sum of the GP series 1 plus 2 plus 2 squared plus 2 to the power n minus 1. Sum of n terms of this GP series would be the numerator of this. And the left hand side is the arithmetic mean of these numbers. The left hand side is the arithmetic mean of these numbers. How about it? Now if I can show that the right hand side is the geometric mean of these numbers, then the problem is solved. Yes or no? Yes or no? Hey, 2 to the power n minus 1 by 2. This right hand side could be written as 2 to the power n into n minus 1 by 2n. So nth root of this. Yes or no? Can I not write it like this? See, it's as if into n by n. So this is the nth root of this. Nth root of n into n minus 1 by 2. Right? Clear? Which is like nth root of 2 to the power n into n minus 1 by 2 is what? Sum of the first n minus 1 natural numbers? Sum of the first n minus 1 natural numbers? Yes or no? I have done, right? Sum of the first n natural, sum of the squares, sum of the cubes, etc. Right? Yes or no? Which is like nth root of 2 into 2 squared into 2 cubed into 2 to the power n minus 1. Yes or no? Which is the geometric mean of these numbers? And these are all distinct numbers, so the equality cannot occur. Arithmetic mean greater than geometric mean. This right hand side is the geometric mean of these numbers. The left hand side is the arithmetic mean of 1, 2, 2 squared, 2 cubed, 2 to the power n minus 1. The right hand side is only the geometric mean of 2, 2 squared, 2 cubed, 2 to the power n minus 1. AM bigger than GM, which is true. Got it? Sounds all right? 13 part 3. X, Y, Z are positive numbers, and it's given that xy plus yz plus zx is 12. We want to find the greatest value of xyz. We want to find the greatest value of xyz. Absolutely. AMGM, straight AMGM. See, xy plus yz plus zx by 3. That's the arithmetic mean of three numbers. And it positive numbers, right? This is one number, this is another number, this is the third number. This must be greater than or equal to the geometric mean of these numbers, xy, yz, zx. This is 12 by 3, which is 4, right? Raising to the power 3, both sides, right? Greater than or equal to x squared, y squared, z squared. What? This is 64. So x square, y square, z squared less than or equal to 64. Which means x, y, z is less than or equal to 8. So what's the maximum value of x, y, z? 8. The greatest value of x, y, z is 8. Right? Let me change matters a little bit. Can I wipe this off? Suppose I have something like this. Say if I give you x plus y plus z, x, y, z are positive numbers, positive real numbers, and suppose x plus y plus z is, say, 10. Okay, and I want to find the greatest value of x squared, y cube, z to power 5. Suppose I want to find the greatest value of x squared, y cube, z power 5. Right? Which means the great, any ideas? You have some suggestions? Oh, not a problem. Oh, very good. I mean, I'll be more than happy to let you do that. Okay. Work around this as a homework.